Factors on which resistance depends. Dependence of resistance on length of wire. Resistance depends on length of wire. We know about resistance. Resistance is the obstruction of the flow of electrons. Okay. So resistance is directly proportional to the length of the wire. That means more is the length of wire, more is the number of collision, and more is the resistance. If length of wire is more, then resistance will be increased. So more is the length of wire, more is the number of collision, and more is the resistance. Next, resistance on area of wire. Resistance is inversely proportional to the area of the wire. More is the area of the wire, less is the resistance, as number of collision is less as they can pass easily. Okay, so resistance is directly proportional to the length of the wire and it is inversely proportional to the area of the wire. Next is resistance on nature of wire. Depending upon the material used for making wires. It's also depend on the material used for making wires. Like conductor have almost nil resistance. Conductor almost have nil resistance. Semiconductor have resistance. Insulator have high resistance. So conductor cannot obstruct the flow of electrons. Semiconductor, so it will have resistance, and insulator have high resistance. Now resistance on temperature. Resistance is directly proportional to temperature for pure metals, but for alloys it decreases. Alloys means mixture of various metals. So with increase in the temperature, number of collisions are more, therefore resistance is more. When temperature is increased, then resistance is more, because number of collision are more, therefore resistance is more. Combining all factor, we get resistance is equal to L/A. Specific resistance on resistivity. Now, resistance can be introduced in a circuit in two ways. Resistance in series like this, R1, R2, R3, R4. When resistance are in series, okay, in series resistance are attached as shown. This is called series. In series, the current remains constant and potential difference changes. In series, current remains constant and potential difference changes. Resistance in parallel, they are connected as shown in figure, parallel ways. This is called parallel resistance. They are connected as shown in figure. In parallel, potential difference remains constant and the current changes. Here you have seen that current remains constant and potential difference changes. But in parallel resistance, potential difference remain constant while current change. Now, derive expression to calculate equivalent resistance when different resistance are connected in series. When resistance are connected in series, then define expression to calculate equivalent resistance. Let's say same current I passes through resistance R1, R2 and potential difference is V1 and V2. Then we can write when resistance are in series like this. When resistance are in series, then what we will do? Then we can write V is equal to V1 plus V2 plus V3 like this. IR1 plus IR2, or we can write R1, R2. Okay. Now expression to calculate equivalent resistance when different resistance are connected in parallel. When resistance are connected in parallel series, then we can write like this. I is equal to I1 plus I2, V oblique R1, V plus V oblique R2. Okay.